Shall I start? Yes?
Yes, ma'am.
Okay. Okay. 1 minute.
Ma'am, you're on mute.
Go to take the circle. Okay. Yeah, just I'm bringing it. Okay. So let's start the presentation. Okay. Have the ellipse. Okay. Ellipse and then circle has to come here. I'll just keep it now. And then oval. Here I'm going to just introduce the name to the children. So this is. Yes. This is.
Ellipse.
Okay.
Ellipse. Circle.
Circle.
Circle, ma'am.
See, this is.
Ellipse.
Ellipse.
Ellipse. Okay. Yeah. Ellipse. And then circle has to come here. Okay. And then just what is this? Circle.
Circle.
And then this is
Oval.
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 oval. Yeah, thank you. So circle. Okay. Just ask the children the names. Names of the curved figures. That's all. Okay. Are they polygons?
No, ma'am.
No? Okay. Why do we why
Because
they
they
are
are
not
not
polygons?
enclosed by straight lines.
Yeah. So what is the criteria for polygons? It has to be bounded by the straight lines. But these figures are bounded by the curved lines, right? So they are not polygons. Okay. Just say the names. That's all. Okay. If you want to bring, see already the etymologies and all given to the child. So here you can ask the child the etymology once again. This is a very simple presentation. So, so what is the purpose of the presentation? This is just make the child aware that these are also shapes. We have many other shapes also which doesn't belong to polygons, right? That's all. Okay, so with this, so what could be the follow-up activities? Yes? What could be the follow-up activities for this?
With the
Okay.
shape. Finding object with the shape. If it is
Okay.
oval, they will say and circle.
They can even trace it, right? Trace these shapes and they can make some designs, right? If they want to make some booklet, they can make it. Okay, so this is a very small presentation. Let's go to the next one. Regular and irregular polygons. Regular and irregular polygons. The purpose prerequisite I'll give you later. Okay, at the end of the presentation, I'll give you. Okay, regular and irregular polygons. Under that, the first presentation will be general exploration of polygons. General exploration of polygons. Okay, yeah. So for this, you need the triangle tray. Okay, have the triangle tray. Okay, if you have 7 triangles, you can use the 7th triangle also. Okay, let's start. Okay. Are you able to see? Okay. Just look at this triangle. This triangle. Okay. Let me try to flip this and see whether it fits in the frame. Let me flip the triangle and see whether this triangle fits in the frame. See, for you to flip, for you I'm saying, okay, just look at any one of the base. Otherwise, we'll try with this so that will be clear for you. Okay. Observe. So how do you flip? You cannot do it randomly, right? That should be one process, right? Okay. So observe the one side. So let us consider this side. Let us fix this side. Okay. And this side, this is one flip, right? Is it fitting?
No.
No. Okay. The same side. Okay. We have to flip one more time and match it with the third side. Is it fitting?
No.
No, ma'am.
Right? We flip twice, right? So twice. One more time. Flipping one more time. Does it fit now?
Yeah.
Yes. Okay. So how many flips it take to fit into the frame? Three flips. Okay. Let's try with the another triangle. Okay. Look at any one side. Right? So I'm flipping it one time. Does it fit?
No.
Does it fit?
No, ma'am.
No. Second time. Does it fit?
No,
I'm
ma'am.
flipping only this side. Okay. Don't flip randomly. If you're not able to understand, ask me. Okay. I'm flipping it thrice. What happens? It fits exactly into the frame. So how many flips it takes?
3.
It takes 3 flips to fit into the frame. So like that. So anybody wants to, anybody is not clear about the flipping? Or everybody?
Can you show shape alone one more?
One more time. Shall I show it with this? Okay. Just fix any one of the side. Let's consider this side. Okay. We are going to check this side, whether it is going to fit on this side and this side, correct? When it is coming back to this side, for the third time only, it will come back, correct? Got it? Let's try. Just focus on this side alone. Okay, let's try. First time. Does it fit?
Yes.
No, ma'am.
Second time. Does
No.
it fit?
Oh.
No. Third time,
Well.
I'm just focusing on this only. Okay, this side.
No, it fits.
Now it fits, right? So like that, you can fix any one side and try to flip that many times. Let us try with this side now. Okay, just focus on this side, the longer side, right? Let's try to fix that here one time. Does it fit? No. Second time? No. Third time? Yes. So it takes totally 3 flips to fit into the frame. Is it clear? Now the flipping, how do we do? There is a process to do that. Don't do it randomly. That will confuse the child. Right? Okay. So like that, you try to flip all the triangles except the equilateral triangles. Okay. So how many flips all these other triangles will take?
3.
3 flips, right? So when you have the 7th triangle also, I don't have. That also you try. So totally 3 flips it will take. Okay. Let's try with the equilateral triangle. Okay. So let us fix this side and check. Just look at this side alone. One time. I flipped it one time. What happens?
It fits.
It fits, right? Okay. So this is how you need to check. Okay. So, this is how you need to flip and check whether the triangle fits into the frame. Okay. So when you're checking the first triangle, so how many flips it take? 3 flips. Okay. So when a shape takes more than 1 flip to fit into the frame, we call it as irregular polygon. We call that shape as irregular polygon. When a shape takes more than 1 flip to fit into the frame, we call it as irregular polygon. That means that polygon is not regular. Okay. So keep the triangle under that. Okay. Now try with the second. How many flips it will take? 3 flips. Okay. So what polygon it is?
Irregular, ma'am.
Irregular polygon. So like that, you go on exploring other triangles. Okay. So keep on exploring the triangles and keep them under irregular polygons, all the triangles. So when you come to the equilateral triangle, let's see how many flips it takes. How many flips?
One flip.
One flip, right? So this triangle is called as regular polygon, as it takes only one flip to fit into the frame. We call it as regular polygon. So now write the name strip for regular polygon and keep it. Keep the equilateral triangle under that. So this is how we classify the triangles, okay, under irregular or regular. Or else you can say this is the exploring triangles. Okay, is this clear? Yes, any doubts here? Yes,
Clear, ma'am. Clear.
clear? Okay, now let's explore the squares and rectangles we have, right? Okay, let's see how many flips this triangle takes to fit into the frame. Okay, fix any one side and see. One flip, I flipped it once, twice. So how many flips it takes?
Two.
Two flips.
Two flips.
So what do we call this? What kind of polygon it is?
It's an irregular. Irregular.
I'm keeping it under regular. Okay, regular polygons like that. So all the rectangles, how many flips it takes?
Two flips.
Two flips. Okay, so all these triangles comes under which category?
Irregular.
Irregular polygon.
Okay, let's come to the square at the end. Okay. How many flips does it take?
One.
How many?
One, ma'am. One flip.
One flip, ma'am.
Right. Okay. So what do we call them?
Regular polygon.
Regular polygon. Keep it under regular polygon. Okay. So this is how you explore all this is a single presentation. Okay. In that subpart only, we explored about triangle and then exploring rectangles and square. Right. After that, we have one more tray. Exploring polygon tray. Polygons. Right? Okay. Let's see how many flips it takes. Okay, let's try with the pentagon first. Observe any one side. I'm going to flip one
flip,
time.
ma'am.
Does it fit?
Yeah.
One flip. So like that, so it's under regular polygons, right? So like that, go on exploring with all the polygons. So obviously all the polygons comes under
Regular
Regular polygon.
display all the, yeah. So let the child explore all the polygons and decide where it goes. So this is how we are going to explore the triangles, rectangles and square and the polygons. Okay, so now after this, why do you think they fit exactly on the first flip itself, these regular polygons?
All the sides are equal.
Equal, ma'am.
All the sides are equal.
Same.
Okay, same. You think all the sides are same. Let's try. Okay, how can we be sure?
Equilateral, square, all the sides are same, ma'am.
Okay, so how can we check that? Are you sure?
We can use ruler, ma'am.
Measuring.
Check the sides.
Ruler, okay.
No,
Right?
and can we
Ruler you can check and then
We can
Children,
draw in the
who are not
paper
into
and
ruler,
check it, ma'am.
you can trace the side. First side, I traced it. Okay, second side. Trace them. Third side. Okay, fourth side. Okay, fifth side. And flip it and check the sixth side. Okay. Trace all the sides and see whether they are equal or not. Right? That also you can do. As you said, you can use a ruler, you can use a thread. Okay. So let the children decide. Okay. So now you all said the regular polygons will have all the sides equal, right? Then what about the angles?
They will also be equal then.
They will also be equal. Okay. How can we be sure? How can we check, Suchi? How can you check?
Now we not yet taught them to use the protractor. No?
Protractor, they have not gone into
Go
protractor.
with that.
This is a very early presentation, right? Then can we check with the insert now? Okay, let's take the pentagon. Okay, I'll show you how to check. Right? Okay, this is the pentagon frame. Okay, so just fix any one angle that you're going to check. Let's fix this angle. We are going to check this angle. Okay. The same, this angle. Okay, the same, all the angles fit into this angle. So that means
The angles are equal.
all the angles are equal, right? Like that, you can flip and see whether one angle, all the angles of the shape fits into one angle. That means all the angles are equal, right?
Ma'am,
Okay.
we can do that for sides also now, ma'am, by flipping.
With the sides also? Yeah, you can do. Yes. Sides and angle, both you can check with this by flipping, right? Okay. So what can you say about the regular polygons?
The sides
All the sides and angles are equal.
then.
All the sides are equal and all the angles also equal, right? Okay, then we call that shape as regular polygons. What do you mean by irregular polygon? What do you mean by irregular polygon?
The sides and angles are not equal.
All the sides. Okay, right? All the sides are not equal and all the angles also not equal. Then we call that shape as irregular polygon, right? Okay. Yeah. Any doubts with this? Yeah. Any doubt in this presentation?
Ma'am, in irregular polygon, there are like polygons which have two sides equal, no ma'am?
Then only I said all the sides.
Okay.
All the sides, see, when all the sides has to be equal and all the angles also should be equal. That we'll do when we come to the pentagon, then you will be very clear. We'll do with the 6 tick box. Just hold on to your question. Okay. Whatever you are asking, just hold on to it. When we come to the pentagon, it will be clear with the stick box. Okay. Yeah. So this is what the presentation is. This is just to introduce the concept of regular and irregular polygons. Let's go to the next one. Further exploration of the concept of irregular and regular polygons. Because we are going to do one more classification after regular and irregular polygon. Okay. Under that, triangles will be the first one. You can write triangles A. Okay, before that, I forgot to tell the purpose, right? Okay, purpose and prerequisite for the previous presentation. What is the purpose? Now you can say. Yeah, Sandhya.
To check whether all the sides and angles are equal.
To check or to give the concept of.
To give the concept of.
Concept of regular and irregular polygon. Okay.
Irregular
And then
polygons.
and also help the child to discover whether the shapes are regular or not. Right? Okay. So this is going to be the purpose. What is the prerequisite for this, Adya? What could be the prerequisite?
Prerequisite could be the previous presentation, sorting of polygons,
Hmm.
then
Hmm.
plane fig. Sorry. All the other previous presentations, ma'am, that we did from with
Yes.
regard to polygons.
Yes. So this can be, yes. Whatever you said is correct. So you can give parallel to the other presentations also, right?
Okay. ma'am.
To other geometry presentation depends on the child's interest with the polygons. Already I told you, right? The lines, polygons, quadrilaterals, everything happens parallel. Okay, based on the child's interest, you can take the child ahead, right? Okay. Then now coming back to this presentation. Okay. So under that concept of, okay, you have written triangles, right? So now we are going to give the concept of equilateral and equilateral and equiangular. Equilateral and equiangular. Okay, so now it is going to be the next presentation, right? It is going to be another session after the regular and irregular polygon. Now you can, by coming to this, you can give a quick recap about, you can ask children questions about the regular and irregular polygons, okay? Let them come up with their definition, right? Give them a quick recap. And then, okay. Now give 3 different sticks to the child. As we don't have time, I just I made the shapes already. Okay, give 3 different sticks to the child and ask the child to make the shape. 3 different sticks to the child. Okay, ask them to make the shape. So obviously it will look like a, what shape it is?
Scalene triangle.
Scalene triangle. Okay, scalene triangle. Okay, so what do you think? Is it regular or irregular polygon?
Irregular.
It's an
Irregular
polygon.
How do you say this is irregular?
Because
all the
sides are all
sides
different.
are
All the angles are different.
All the sides are different. Okay, all the sides are different, or they are not equal. And then what about the angles?
Angles are also different.
Angles also not angles also different, right? Okay. So you said the sides are not equal, right? So when the sides are not equal, we call it as non-equilateral. Non-equilateral. They are not equal, basically. So you can now tell the etymology. Yes. What is the etymology?
Equal means same.
EQ
Lateral means sides, not equal sides.
not equal sides, right? Obviously. Okay. Non-equilateral. Okay. Now let us write in a slip and keep it. Non-equilateral. I have written in blue. Okay. You can write it with the pencil. Okay. Then what about this? What about the angles? Are they same? Are they same?
No, ma'am, angles are different.
Angles are different, right? So then if the angles are different, we call that as non-equiangular. Non-equiangular. Okay, so this triangle is non-equilateral and I've written in red. Use the red pencil. Okay. This shape is non-equilateral and non-equiangular. Okay, Famita. Yes, what is the name of the shape? What do we call this shape?
Scalene equilateral. ma'am.
That is okay. So what is category? So is it regular or irregular?
It's irregular.
Irregular. So under irregular, how can we name this?
Equilateral.
So look at the sides now. How are they?
Irregular.
Are they equal?
No, not equal.
Not equal. Then we call it as non-equilateral, right? Non-equilateral. And so look at the angles now.
Non-equal angular.
Yes, exactly. Non-equiangular. So this shape is called non-equilateral and non-equiangular. Got it, everybody? Yes? Any doubts here? Okay. Now give 3 same sticks to the child. 3 same sticks. And ask the child to make the shape. Let's keep this aside. Okay. So Sangini, just look at the sides of this triangle. How are they?
Equal.
Equal. So we call it as equilateral. As the name says, all the sides are equal. Equilateral. So look at the angles and say, how are they?
Angles are also equal.
Equal. Then we call it as, when the angles are equal, we call it as equiangular. So this shape is equilateral and equiangular. You got it? Hong?
Yes.
Hong, you there?
Yes.
Yeah. So what do we call this shape?
Equilateral
Hmm.
triangle.
That is equilateral triangle. Okay.
Yeah.
But what is the category it comes actually?
Regular.
Regular. Okay. So, but look at the sides and say, is it equilateral or non-equilateral?
Equilateral.
Equilateral and
And
look at
equiangular.
equiangular. So this triangle comes under equilateral. We can say equilateral and
Equiangular triangle.
equiangular. Right. That's all. This we have given, as we have given the irregular and irregular polygons, here we have given equilateral and equiangular. Right? Got it? Any doubts here?
This is for only triangles we do this, ma'am. Because it is also same side only, same angle only.
Okay, wait. Let's see. Is it possible with other shapes and all? We'll see. Okay. Now, Joshla, what could be the purpose of this presentation? Purpose and prerequisite.
To give the concept of both the regular and equilateral and equiangular triangle.
Okay, yes.
And,
Equilateral and equiangular concept, right? That is what we
Triangular,
have. That is what we have given. Okay. And when can we give this presentation?
Like the previous one, the parallel presentation. And once they are sorted, this triangle.
It is parallel, but actually, what has to be done before this?
They should know the angles, different types of angles.
No. Then?
Regular and irregular.
Regular and irregular.
Regular.
Right? Okay. From there only we are starting that, right? Okay. Is it
Yeah.
regular or irregular? Like that only we start, right? So that could be the prerequisite. Okay. It's clear now, right? Let's go to the next one. Okay. B. So triangles we did, right? With the stick box. The same thing on further exploration of concept of regular and irregular polygons. That is what A, that is the triangles, just now we did. The B will be quadrilaterals. Quadrilaterals. So that we are going to do with the geometry tray. Okay. Yeah. Have the quadrilateral tray. Okay. Kavya? Yeah. So which shape do you think we have here? We have 4 shapes, Kavya. Okay. Which shape do you think which is most irregular? So here we have in all these.
Near to the trapezium.
This one.
Yeah,
no?
this one. Yes,
This one. This one.
this one and this one also.
Both.
Yes,
Which is most irregular?
most irregular is this near to the trapezium.
This
Yeah,
one,
this
right?
one.
Why do you think
Yes.
this is most irregular?
Because all the sides are not equal.
All the sides are not equal. Right. Okay. What about the angles?
Sorry, angles are not equal.
Is it so? Is that so? I'll show you.
No, like two
All the
sides are
sides
equal.
are
Yeah. Two sides are equal.
All the sides are not equal. That is what you said. Correct. All the sides are not equal. What about the angles now?
2 angles are
So,
equal.
like
2 angles are right angles, right? Okay. That's why you call it as most irregular shape here, right? Okay. This is right angle, trapezoid or trapezium. Okay. Whatever you call. But it has one right angle here. Okay. Now, let's check how irregular it is. Okay. Let's fix any one side and flip and see how many flips. So, do you have any idea about how many flips it takes? Anybody?
3, ma'am.
3, yeah?
4, ma'am.
4,
4.
ma'am.
Okay.
4.
Okay. 4, 3, 4. We got different answers. Let's try. Okay. Let me fix this side, the longer side, and see. 1. I flipped it twice. Thrice. So how many flips?
4.
4. Okay. It took 4 flips to put into the frame. Right? Okay. Irregular. Okay. Let's keep that separately. Here, I'm just keeping it separately. As we are discussing about the shape, I'll show you at the end here. Okay. I'm just keeping it separately. Okay, now let's go to the parallelogram. So this is parallelogram. Okay, do you think this is regular or irregular? Somebody else. Wait, Geeta, you there? Geeta?
Yes, ma'am. Yes, ma'am.
Yeah,
Yes,
yeah.
power off. So I was just, I didn't
so
hear you, ma'am.
is it regular or irregular?
Irregular, ma'am.
Irregular. Okay,
Yeah.
how it is irregular?
Two sides are equal, ma'am.
4 sides are parallelogram. This is
Yeah.
compass.
Yeah, two sides are equal.
All the 4 sides equal. Parallelogram. We are talking about parallelogram.
Yes, ma'am. Yes.
Then,
It's regular polygon.
is it regular? Okay, let's talk about the sides first. So, what about the sides? Are they equal?
Yes, ma'am.
All are equal?
Yeah.
Opposite.
Only opposite sides are equal.
Opposite sides are equal. Okay. What about the angles? And they are parallel too, obviously, right? Okay.
Yeah.
What about the angles now?
Angles are all equal.
Opposite angles are equal. So let's say 2 angles are equal and these 2 angles are equal, right? Okay.
Yes, ma'am.
So then it is irregular, right?
Yeah.
Now somebody asked the question, right? We have some other polygons also which have 2 sides equal. So that is what I said. For a polygon to be regular, all the sides has to be equal and all the angles to be equal. Here you have two angles equal and here two angles equal. But this is not regular, right? Got it?
Is it all the angles are not? I think all the angles are equal.
Ma'am, in this one, aren't all the
No.
angles equal?
See,
Are they not?
these two angles are obtuse. These two
Oh.
angles are acute. How it can be then?
Ma'am, from here they all look like right
Yeah,
angles.
that is
ma'am.
what. Just think about the parallelogram. See, that is
Okay.
what. Okay. Okay. So now, so it is irregular, right? Okay, let's keep it separately. Let's go to the trapezium. Okay, so 1 minute. Yeah. Now let's go to the trapezium now. Okay. What do you think? Somebody else try?
Two sides.
Irregular polygon.
It is irregular. How? What about the sides?
Angles and sides
All
are
the sides are not equal.
Let's talk one by one, right? Okay, what about the sides first?
not
Sides.
equal.
Not equal? What about these two sides?
Sides are equal. One side only it is.
Only these two sides, not opposite sides. Okay, one pair of opposite sides are equal. Correct? Okay, what about the angles?
Same one opposite side.
Opposite
No, ma'am, on the same
Adjacent.
plane, the
Adjacent
adjacent
angles.
angles are equal.
These two adjacent angles are equal and these two adjacent angles are equal. Okay, that it is irregular, right? Okay, sorry, one more thing. We didn't check with the how many flips it takes, right? For the parallelogram, let's check. How many flips it takes?
2 flips.
One,
ma'am.
2 flips, right? It takes 2 flips. Let's keep it aside. Now, let's check with the trapezium. How many flips it takes? The trapezium.
4.
4,
4, ma'am.
4. Are you sure? Let's try.
4.
1, 2, 3, 4. Correct. 4 flips it takes. Okay. Let's keep them separately. This is how you need to keep. You'll know why at the end. Okay. Now we left with rhombus. This is rhombus. Okay. I don't know. So when I'm bringing it closer, the angle changes. This is rhombus. Okay. Okay. What about this? Is it regular or irregular?
Irregular, ma'am.
Irregular. Okay. What about the sides?
And the sides are equal, ma'am.
All the sides are
Sides are
equal.
equal, ma'am.
Okay. What about the angles?
Ma'am, the opposite angles are equal.
Opposite angles are equal. Okay. Then it is?
Angles.
Then it is regular or irregular?
Irregular. ma'am.
Irregular polygon. Okay. Let's keep it here. I'm just bringing it closer for you to understand. Okay. This is trapezium and this is our trapezoid, right angle trapezoid. And then here we have rhombus and here we have parallelogram. Okay. Now, just observe. This is a square. I'm just bringing a square in between the trapezoids. Rectangle. Okay, keep rectangle in between rhombus and the parallelogram. Okay. So among all these shapes, okay, how many flips it takes actually? This trapezium or trapezoid, how many flips it takes?
4.
4. And this right angle trapezoid?
Also 4.
4. And the square?
1.
1. Okay. Coming to the rhombus?
1 flip. 1.
1. 1 means it has to be regular.
2 flips. ma'am.
2 flips. Okay, if you want to check again, you can check. Okay, while you're keeping it here itself, check the number of flips. Okay, 2 flips it takes, right? Okay, What about the rectangle?
2 flips, ma'am.
Two.
It's
Two
2
flips.
flips.
And then here,
Also 2 flips.
two flips. Okay. So how do you think these are related? Among all these shapes, okay, this is only one thing. The square is the only regular shape, right? Among all these 6 shapes, which is the regular shape?
Square.
Square. Only the square is the regular shape. All the others are irregular, right? How much irregular it is? This takes 4 flips, this takes 4, and this takes 2, and this takes 2, this takes 2. Okay. Which are related now?
On this.
Which are related?
On the square, rhombus, rectangle, and parallelogram are
Square,
related.
1 minute. Square, rhombus,
Rectangle and parallelogram.
and parallelogram. Rectangle and all these 4 are related. Okay. Anybody else? Which shapes are related? Yes.
Rhombus, rectangle, and parallelogram are related.
Rhombus, rectangle, parallelogram are related. How they
Yeah.
are related?
They took 2 flips.
Yes,
2
exactly. These 3 shapes took 2 flips to
So they are
fit it to the frame, right? Okay, they are related. Then what else are related?
Trapezium and trapezoid.
This is trapezium and right angle
Yeah.
or trapezoid. Okay, so
Both.
both are related. How they are related?
It takes 4
Four
flips
flips.
to fit in the
This takes
frame.
4 flips, right? Okay, so both are related. These 3 are related and these 2 are related, right? Okay, so this is how you're going to discuss about the relationship. Got it? We have one more in the same presentation. Okay, I'm going to continue. Are you all clear with this? Any doubts? Any doubts, Surya?
Ma'am, won't the children observe this relationship? Or should we
Yes, that is what. That is how. That is what. Before keeping the shape itself, we are keep on checking the number of flips, right? What is the focus we have here? So in all these presentations, we are just checking the number of flips the shape each shape takes, right? That only decide whether it is regular or irregular. Right. So when you're asking the child, is it related or not? There also you're just bringing their attention to the number of flips it takes.
Okay.
Yeah. So then the children, they'll be able to answer, right?
So, ma'am, what's the purpose of introducing the square, ma'am? Because even without the square, if we just have the 5 shapes and we ask the children the question, which are the shapes that are related, they'll be able to do it.
Okay. Well,
Why
do
do
you
we
think
introduce
I
a square,
brought these
ma'am?
two? Okay. Why do you think I have brought these two? Anybody?
Rectangle is related.
Rectangle is related. Okay. So why do I need to bring the square here?
4-sided polygons.
Yes. These are the quadrilaterals we have. Right. Yeah. Got it, Suji?
Yes, ma'am.
Yeah, so these are the quadrilaterals we have. We already explored the square and the rectangle separately, right? Now we are going to explore all the quadrilaterals together and we are going to link this with the equiangular and equilinear now. That you will understand. That is the second part of the same presentation. We'll do with the stick box, right? You got it clear? Okay,
Yes,
with the
ma'am.
same presentation itself, after bringing the relationship, we are going to work with the stick box. Okay. Yeah. So ask the children to make, give the proper sticks to the children to make a parallelogram. I made it already. Okay. A parallelogram, square. We have rectangle. Let's make it as a rhombus. Rhombus, square. Okay. And equilateral triangle. And then we have right angle trapezoid. Okay. The shapes, whatever we discussed now. So that is what we are going to make with the stick box, right? All these shapes. And what else you have? Sorry, this is the trapezium and this is the right angle trapezoid. Okay. Okay. Also we can bring the scalene triangle also. Have you noted down these shapes? We made square, rectangle, rhombus, parallelogram, and then right angle trapezoid and trapezium. Scalene triangle, equilateral triangle. Got it? Yes. Ask the children to give that many sticks, and or you can ask the children to name the shape and ask the children to make whichever way. Okay. Now, let's keep the shapes aside. Let us discuss about the shapes. Okay. Trapezium. Okay, think about the sides and the angles. Okay. Say whether it is equilateral or non-equilateral, equiangular or non-equiangular. So like that we are going to do. Okay. So consider this shape, trapezium. Just tell me the name. Asha? This is
Non-equilateral and non-equiangular.
non-equilateral
And
and
non-equiangular.
non-equiangular. Okay, let's place the slip. Non-equilateral and non-equiangular. Let's keep it as a heading. Just we are going to classify. Okay, the same one we used it. Non-equilateral and alone red, highlighted in red. Okay. Now bring the right angle trapezoid. Archana, what do we call this?
Non-equilateral. Yes, non-equilateral and non-equiangular.
Okay, fine. We keep it under this, right? Okay. Now, coming to this shape, rectangle. Anybody else want to? Anupama? Want to try? What do we call this?
This is not all the sides are equal, no ma'am. So it is non-equilateral.
Non-equilateral. Is it equiangular?
Even non-equiangular only, ma'am, because only opposite sides are opposite angles.
That's so. Is that so, Anupama? This is rectangle.
Okay. Okay, I thought it would be a parallelogram.
Yeah. So for you to see it from here, the angle actually changes. This is rectangle. Okay.
Then all the angles are equal.
Equal. So then we call it as non-equilateral, but
and equiangular.
Not and, but it is equiangular.
Okay.
But so here I'm going to use the conjunction word but. Okay. Let's keep it separate. So this is going to be non-equilateral, but in red. Okay, but I have written in red. But equiangular. Okay. Let's try the some other thing. This one. Imtiaz?
Yes, ma'am. Equilateral triangle. All sides are equal.
Just say the name. Which category it comes under?
Equilateral and equiangular.
Equilateral and equiangular, right?
Yes.
We keep them separately. Equilateral and equiangular. Okay, equilateral. And equiangular. Okay. Now, this one. Ram? Square.
Yes, ma'am. It's also All sides are equal and all angles are equal.
Then
Equilateral, equiangular.
equilateral and equiangular.
Equiangular.
Okay. Preeta. Rhombus.
Rhombus equilateral but non-equiangular.
Equilateral but
Opposite.
Equilateral but non-equiangular, right?
Yeah.
Correct. This is equilateral but sorry, this is actually equilateral but non-equiangular. Okay, let's keep the label. Equilateral but non-equiangular. Okay, now coming to the next shape, parallelogram. Who wants to try? Neha? Neha, you there? Neha, you there? Okay, Vishaka, you want to try?
Yes, ma'am. It is non-equilateral, non-equiangular.
Then non-equilateral and
non-equiangular.
This, okay, the same group. Okay. Now we left with only one shape. Lalita, unmute yourself.
Non-equilateral and non-equiangular, ma'am.
Non-equilateral
And non-equiangular.
and non-equiangular. Let's keep it here, right? Okay. This is how you are going to classify. The same thing, whatever we did with the geometry cabinet, right? The thing we are going to do with the stick box. That's all. So, are we clear? Any doubts? Any doubts we have here till now with the non-equilateral, equiangular, right? So till now we explored with triangles and quadrilaterals with the stick box also, right? Okay. Any doubts? Because next presentation you are going to do it yourself. Any doubts? Let's go to the next one. It is very similar to the last one. Okay. Now we are going to explore about polygons. Okay. The same thing. Okay. The equiangular and equilateral, the same concept we are going to explore with the polygons in the next presentation. Okay. So now we can discuss about the prerequisite and the purpose. Yeah. Who wants to? Suchi? What is the purpose and the prerequisite for the previous question, whatever we did just now?
The prerequisite would be, the presentations they've done before, as in, with working with polygons. And the purpose would be to is it to explore the concept of equilateral and equiangular polygons?
With the quadrilaterals.
Quadrilaterals.
That's what just now we did, right?
Quadrilaterals.
Okay, fine. Now we are going to same thing. We are going to do it. When you understand the previous presentation, it will be very easy. Okay, with the same thing, we are going to do with the polygon. So now I'm going to take one of the polygon. Okay, pentagon. That is what I'm going to take. Okay, so now give the same number of sticks. Okay, so how many sticks we need? 5, right? Okay. So give 5 sticks to the child and ask the child to make the shape. So Do you think anything special about this? How did I
Unequal
choose
side.
the sticks? How did I choose the stick?
Unequal side.
They're all different, ma'am.
They're all different.
Different
Are you
shapes.
sure, Suchi? All are different.
No, ma'am, two are the same.
Two sides
Two are
are
the
the
same. Sorry.
Two. See,
Two are
this is the preparation for you. Okay, write it under preparation. 2 sticks has to be equal. Okay, for you to go to this presentation. Okay. Okay, ask the child to make a shape. So obviously the children, they make the pentagon, right? Okay, is it regular or irregular now?
irregular, ma'am.
Irregular, right? Okay. So how, why do you think it is irregular? What about the sides?
Only two sides are the same.
Only
and
2 sides are equal, right? Okay. What about the angles?
all of the angles are different.
All of the angles are different, right? Okay. So so a pentagon, this is a pentagon, right? So a pentagon can be irregular even if all the sides,
Even if two sides are same.
So even if 2 sides are equal, right?
Well, yeah.
Here we have 2 sides are equal. With the first presentation, somebody asked the same question, right? With the polygon, when we have 2 sides equal, whether it is going to be regular or irregular. So this is the answer for this. Even if you have 2 sides equal, this is actually irregular. Why it is irregular? All the sides are not same. Right? All the angles also not same. So what is the criteria to be irregular? All the sides has to be same and all the angles has to be same. Only when these 2 criteria are satisfied, then only we call a shape to be regular. Got it now? Yes? Okay. So now that is what we are going to discuss with the children about the sides and the angles. Okay. So a pentagon can be irregular even if 2 sides are equal. So then this pentagon is what
Irregular.
irregular. Okay. Now now talk in terms of equilateral and equiangular.
It is non-equilateral and non-equiangular.
This is non-equilateral and non-equiangular. Right? Okay. Now give 5 same sticks to the child. 5 of same length. Okay. But intentionally make the angles to be unequal. Okay. That is your preparation. After the children, they passed and did, make it unequal angles. You will understand why. Okay. So now observe this pentagon and tell me, is it regular or irregular?
It's regular.
Irregular.
Irregular. Okay. What about the sides?
Sides are equal.
All the sides are equal.
Equilateral, but non-equilateral.
Yes, because the angles are not equal, right? Okay, so this is equilateral, but non-equiangular. Let's keep the slip. This is equilateral, but non-equiangular. Got it? Any doubts with this? Okay, now I'm going to give 5 same sticks. So intentionally make all the angles to be equal. Okay, let's explore this pentagon now. Is it regular or irregular?
Regular.
Regular,
Polygon.
equilateral and equiangular.
So all the sides are equal. So it is equilateral. All the angles also equal. So it is equiangular. So we call it as equilateral and equiangular. Equilateral and equiangular. Got it? So now you understand why do we make intentionally, why do we prepare something, right? So here we have chosen 2 sticks to be equal, and after for this pentagon, after the child made the pentagon, we made it unequal angles. Here we made it equal angles. Now you all understand, right? So So this pentagon is a regular or irregular?
Regular.
Regular, ma'am.
So, okay. So coming to this pentagon is irregular because
Sides and
Sides
angles are
and
equal.
angle are
Angles
not
are
equal.
not
even if the two sides are equal, all the
Ma'am.
angles are unequal, all the other
Are
sides
unequal.
also unequal. So we call it as irregular. So what about this pentagon? It is
It is also
Regular.
irregular because
though all the sides are the same, all
Hmm.
the angles are not equal.
but all the angles are not equal. Okay. Coming to this,
This is a regular
Regular.
polygon because all the sides are equal and all the angles are also equal.
equal. Okay. Yeah, got it. So if the child wants to measure the angles and be sure all the angles are equal, so how can you help the child? So the flip, we cannot do this, right? With the geometry cabinet only we can do.
No, ma'am.
What we can do with this to check this angles?
Right angle draw, ma'am.
Right angle measurer.
Right angle measurer.
No, they can draw and flip it and can draw and see whether it is equal or not.
Okay, then what else can be done? Why did you say right angle measurer?
With that they can say, ma'am. With the same color, they can say at the sides are equal, ma'am.
I don't understand. What is it?
If you are using the same color, they can say that the sides are same, ma'am.
Sides are same. That we understood. We are talking about how do we check the angles. Yes. Got any idea? We talked about it already.
And by using the right angle measurer, the child may tell whether it is less than right angle or greater than right angle.
Okay. Okay. Let's consider about this now. Okay. Come to this pentagon. Okay. Here. I'm using the right angle measurer. Okay. So what can you say now? I'm going to say two angles are right angles and all are and other angles are acute. So it will not give you the exact measurement, right?
No, ma'am, but we
You're
know.
coming to this here, you have all the angles are acute angle only. All the 5 angles will be obviously they are less than 90 degree. How will you check them?
Trace it on paper and
something similar to right angle measurer. Do we have anything? We talked about already. What about the measurer for all the polygons, all the regular polygons, right?
ma'am,
The angles meet at same point. Ma'am? If the angles are meeting at same point,
you can make, right? The angle measurer for all the polygons you can make and keep it in.
Ma'am, can you hear me?
Yes, Neha.
Ma'am, yeah, actually, when you were calling out my name, my laptop got hanged. I couldn't access my phone.
Yeah, understood, Neha. Yeah, you were there, but you were not responding. Yeah, understood. Okay, so you can use the angle measurer for that particular polygon. Okay, make angle measurer for all the regular polygons. Okay, have them in a pouch so that you can use it, right? Okay, so this is going to be the last presentation in the under polygons. Yeah, under polygons. We finished. Okay, so here we have one assignment.
Ma'am, one second, ma'am.
Ah.
When we are making this angle measurer for the, maybe, for example, pentagon, if we are using different geometric sticks, is it going to work, ma'am?
Try.
Okay.
What do you think? Will it work? When sides are not same.
No, ma'am. I'm saying for this, the pentagon with equal sides you showed us now is a small stick, no?
if I do it with a bigger stick also.
Also, this one. How will you check the angles? That is what you are
Yes.
asking.
Yes, ma'am. Yes, ma'am. With
Yeah,
the
yeah.
measurer.
You-
With the measurer.
with the measurer, you can check. See, I have a pen and measurer. Yeah, I have. So here, just coincide the pentagon, one of the angle. That's all. Has to be coincide. That's all. You're going to check only the angles, right? Why do you worry about the length of the stick?
Okay, ma'am. Okay.
Okay. Yeah. That is what I said. Make the this measurer with the regular polygons. Then only it will work. Got it?
Okay, ma'am. Okay.
Yeah. So we have an assignment with the blue scaling triangles. Okay. You have around 10 or 11 triangles you have. Okay. In CASA itself, in CASA environment itself, we have the blue scaling triangle. So with that, you can make some designs. Okay. I'll share you some designs. Okay. Yeah, I'm not able to share. Ma'am, ma'am,
Yes, Sangeeta. Yes, yes.
please, yeah, enable the share option, ma'am.
Done, Sangeeta. Done.
Yeah, thank you. Okay, so with the blue scaling triangle, around 10 to 11 blue scaling triangles you have. So with that triangles, you can make some different shapes. That is what I'm going to show you.
Ma'am,
yes.
can you repeat the material name again?
Scalene triangles.
The constructive triangles.
Yeah, in the constructive triangles, you have seen some boxes, right? Triangle box, rectangle
Yes,
box.
ma'am, you are shown us.
Hexagon, large hexagon. So apart from that, we have one more box that is called blue scaling. Only scaling triangles will be there. So
Okay,
like
ma'am.
this. Okay, only scaling triangles. Okay, all of same size. So like this, you can make some designs. Okay, this is going to be your assignment. It can be handmade. You can take the blue scaling triangle, trace it, and you can move around it, and you can make the designs, or else you can create it in the system, whatever it is. Make at least 10 designs, each of you, so that everybody can share the design. So these designs, you can have some samples in the environment, so that the children, they can make their own. But apart from that, you can have some samples also.
Ma'am, here have you used the pen to make these?
No. I just use the, that day I showed you, right? With the PowerPoint, I have the blue scaling triangle. Just have the template of blue scaling triangle. Okay, just move around them. In the PowerPoint, it will work. Easily you can make. And then you can copy that and paste it wherever you want. Got it? This is going to be your assignment. So each of you, at least 10 designs you have to make. Got it? Yes? Any doubts with the... okay, so while making the assignment also, please be conscious that, okay, so what are the parts of this triangle? This is a scaling triangle. Okay, what are the parts we have? In the right angle triangle.
Sides.
Base,
Ma'am, base,
minor
right
leg.
angle, hypotenuse.
Both are
Height.
legs.
Yeah.
But these two are different. So this is minor leg and this is the
Major leg.
major leg. And this is your
Hypotenuse.
Hypotenuse. Yes. So while making the design, you please aware that, okay, how you're going to make the design. That is what you're going to concentrate and you're going to do. Okay. So whether you're going to, see, let's discuss about one thing. Let's take one design.
The adjacent sides should be of the same.
1 minute. Let's take this. What is it? MTS, what you were asking?
No, I was saying that the adjacent sides should it be of the same, either minor or major or hypotenuse?
So that is the nomenclature of the, we'll do it actually. It is a presentation. Okay, nomenclature of the right angle triangle. So in so right angle triangle, two types you have, right? One is scalene right angle scalene triangle, and right angle isosceles triangle, right? When it is an isosceles triangle, both legs are equal. Leg or side, whatever, cathetus. You can say even cathetus. Okay. So both are equal in isosceles triangle, right? So then we call it a simply leg, cathetus or side, right? Here in scalene triangle, both are unequal. So the shorter length we call it as minor leg or minor cathetus. The longer one we call it as major leg or major cathetus. This is the hypotenuse, right? So how we are going to join, that is what you're going to concentrate. Okay. So here, let's discuss about this. How did I join this? Actually, yeah. So here I joined the hypotenuse with the major leg. Got it? Yeah, continuously I joined the hypotenuse with the major leg. At the end, I got this design. And outside also you get a polygon, and the same polygon I got it inside also. Do you see that? Yes. Let's discuss about this. How did I get in?
Same thing, ma'am.
Same thing, ma'am, but in different.
Same thing. But both are different.
Major legs. Two major legs.
Major leg.
Yes. Okay. Hypotenuse with a major leg, but you get different designs, right? Okay. Here, minor leg aligning with the hypotenuse, right? Not exactly matching, but actually the minor leg of one triangle lies on the hypotenuse of the another triangle, correct? Yeah. So like that, you can try different things and just see to it how you are going to align that. Okay. Yeah. Which one? 1 minute. I'll show you this one. Here we joined only the vertex, that's all. Okay, like that you can, here we join the minor legs. Right. So like that you're going to try. Here both hypotenuse. Got it?
So there are no conditions. We can try any.
You can try with any combinations, but actually be aware that how you are going to make the shape. That's all. Okay, when you're constantly following one condition. So when I say you need to join the hypotenuse and the minor leg. Okay, when I say that, so you have to constantly follow the same thing.
Should I? Yeah, because in some of them they seem to be. They don't.
Yeah, that is what. So when you're constantly making it, constantly following the same rule, you get another shape, right? So in between, when you change the rules also, you get some different designs.
Yeah.
But you need to be aware that how you are going to make the design.
Okay.
That's all.
Fine.
Okay, which part of the triangle you join together. That is what.
Got it.
Got it? Okay. Yeah, so that's all. Any doubts with the assignment?
This is tracing the shape, ma'am, geometrical shape, or how we have to do
that is what that is left to you, Ram. Actually, two choices are there. You can either take the blue scale in triangle, right? You can make it on the mat and you can take a photograph. Okay, if you are available with the blue scale in triangle. Okay, and one more thing, you can trace the blue scale in triangle and you can draw it on the paper itself. Trace it and do. And otherwise, the third option will be you can make it in the system. PowerPoint will support you for that. Okay, yeah. So at least 10 designs you have to make. Okay, make it into a, yeah. So whatever way you want, you can make it. Come up with different creative ideas, right? Okay, yeah. Ma'am? Ma'am?
Yes.
Yeah, ma'am. We have time, right? Shall we continue with quadrilaterals, ma'am? We finished with polygons. The first presentation, hello?
Finish with polygons, huh?
We finished polygons.
Okay, so you would like to continue with the quadrilaterals?
You have to say, ma'am, the first presentation, not the family tree and all. The first presentation.
Yeah, I think we can do that.
Yeah, we can, right? We have time. Yeah. So here we are going to talk, start with another new topic, that is quadrilaterals. We already discussed, right? Many presentations, they go and go parallel, right? In geometry. What are they? Yes. What are the topics that can go parallel? Yes. Yes, what happened? What happened? Why nobody is answering?
Introducing shapes and then irregular polygons.
Lines also can be parallel.
Lines also can be parallel. So what else can be parallel?
Angles and all the activities of polygons.
Yes, all the activities of polygons can be parallel. And yes. Okay, with that, you can take the quadrilaterals also. Quadrilaterals can be parallel. Okay. So based on the interest of the child, we are going to take it forward. Okay, so here we are going to discuss about 7 quadrilaterals. So how many triangles of reality we have?
7, ma'am.
7. Okay. So quadrilaterals also we have 7. Okay, what are they?
Square, rectangle,
Square, rectangle,
trapezium, right angle, trapezoid, parallelogram.
Let's write it in order. Okay, let's start with the common quadrilateral. Just write it down. Common quadrilateral. Common quadrilateral, that is the first one. Trapezium or trapezoid. That is the second one. Parallelogram. Rectangle. Rhombus. Square. So how many we have?
6, ma'am.
6. That is a trapezium and right angle.
Right angle.
We had, right? So 7. Totally 7. So 7 quadrilaterals of reality. That is what we are going to discuss here also. Okay, so this is the list I have given you from general to specific. Okay, you can see we started with the common quadrilateral. We end up with the
Square, ma'am.
square. So the common quadrilateral is most irregular, right? We talked about it already. The quadrilateral, how it was, the one quadrilateral we made, right? Common quadrilateral, or you could say this is the common quadrilateral. This is most irregular, right? Most irregular to a regular quadrilateral, that is your square. So we'll discuss it in detail now. Okay, so here also we are going to use the stick box. The purpose is going to be help the child to identify the quadrilaterals by shapes. Sorry, one more thing we missed it, right? Kite. We missed the kite. In the 7 quadrilaterals, you write just add the kite also. We missed the kite. Okay, and then the second purpose will be help them to learn the terms like common quadrilateral, trapezium or trapezoid, parallelogram, rectangle, kite, rhombus, square, everything. To learn all these terms. That's all. So the prerequisite will be the child should have worked already with the polygons, parallel lines, and angles. Polygons, parallel lines, and angles. Okay. This is going to be little later in elementary. Okay, not a very early presentation, little later. Because the children, they should have worked at least with all these three, right? Okay, so you understand why the children, they should know all these three about parallel lines, polygons, and angles when we are doing the presentation. Okay, let's start with that. Okay, so here also.
Ma'am, so sorry, ma'am. This is a new topic, ma'am.
New topic.
Like
This is a new topic. Okay, quadrilaterals. Okay, so the first presentation will be types of quadrilaterals. Types of quadrilaterals. Okay, so now you're going to give that many sticks to the children, appropriate sticks to the children to make all the 7 quadrilaterals, whatever we said just now. Okay, common quadrilateral. Okay, give that many, the appropriate sticks to the children. And okay, trapezium, common quadrilateral, trapezium we made, and we made rectangle. Okay, we made parallelogram. So here you're going to give that many sticks to the children. So children, they are going to make. As we have short of time, I made it. Okay. And then we need, what else we need?
Rectangle, square.
Square.
Rectangle we made.
Rhombus.
Parallelogram we made.
Rhombus, ma'am.
Rhombus and square.
Rhombus and square. Yeah, we made rhombus and square.
Kite.
Okay.
Kite.
Then
Kite.
that is the 7th one, right? Kite. I made a kite. Okay. So all these 7 shapes ask the children to make. Okay. Let's start. Shall I start? Okay. So here we made the quadrilaterals, right? You know what a quadrilateral means. What a quadrilateral? What is a quadrilateral?
4-sided figures. It has 4 sides.
4-sided shapes, right? So all these shapes, they made up of 4 sides, right? So all these shapes are called as quadrilaterals. Okay. Now, let's discuss about the shapes one by one. Bring the common quadrilateral. Okay, now, just observe this quadrilateral. Do we have any equal sides? No, none of the sides are equal. What about the angles?
None of the angles.
None of the angles are equal, right? Okay, so we call it as common quadrilateral. Got it? Common quadrilateral. Write a name. As we have none of the angles are equal and none of the sides are equal. Okay, right? We call it as common quadrilateral. Okay. Look at this shape. What is this? Okay, what can you say about this shape? It is a quadrilateral. What can you say about it?
One set of 2 sides are equal. Two parallel sides
are equal. Okay, only one pair of sides are equal, right? Not all the sides are equal. Only 2 sides are equal. And what about the other 2 sides? These 2 sides are equal. Okay, these 2 sides are equal.
These 2 sides are unequal.
Sides are not equal.
But they are parallel.
Parallel.
They are parallel to each
other. Yes, they are running parallel to each other, right? So we call it as trapezium. Okay, in a trapezium, we need 2 sides to be equal and the other 2 sides has to be parallel to each other. Then only we call it as trapezium. Got it? So write a name for trapezium. trapezium. Now, what about this shape? What about this quadrilateral? What do you observe?
Parallelogram. Two opposite sides are equal.
Okay.
Pairs of opposite sides.
This opposite side are equal and this opposite side. So two pairs of opposite sides are equal, right? And also, is there anything
Two
other?
pairs of opposite sides are parallel.
Parallel. Okay. Yes. So we need. So it is. We call it as parallelogram. So for a parallelogram. For a parallelogram, we need opposite sides to be equal and parallel. Got it? For a parallelogram, what is the criteria?
Opposite sides should be equal and parallel.
Yes. So then we call it as that quadrilateral is called as parallelogram. Okay. Let's go to the next one. What about this? Just observe the quadrilateral.
Rectangle.
Rectangle.
Opposite sides are equal.
Opposite sides are equal and
all angles are to be right angle. Opposite sides are equal and parallel, ma'am.
Yes. Opposite sides are equal and parallel. Then what about the angles? Is there anything special about the angles?
They are all right angle.
They are all right angle. So we call it as rectangle. So for a rectangle, opposite sides has to be equal and parallel and all the angles has to be right angle. Then we call that quadrilateral as rectangle. Got it? Okay, rectangle. Let's go to the next one. What is this? What about this quadrilateral?
It's a kite.
Okay. What do you observe with this?
Two adjacent sides.
One pair of opposite sides are equal.
What is that?
One pair of opposite sides are equal, ma'am.
Opposite side? Are they opposite?
Adjacent sides.
Adjacent sides. Right. Two pairs of adjacent sides
are
equal. Okay. And what else can we say? None of the sides are parallel, right? Do we have any parallel line, parallel sides?
No, ma'am.
No. Okay. So then we can say this as kite, which has no parallel sides and adjacent sides are equal. I'll repeat again. We can say this as kite, which has no parallel sides and adjacent sides are equal. We call it a kite. Kite. Okay. Now, what about this?
All the sides
are equal and opposite sides are parallel.
Okay. So, this we call it as rhombus. Alright. Rhombus. All the sides are equal and opposite sides are parallel. Right? See? All the sides are equal and opposite sides are parallel to each other. Then we call it as rhombus. Okay. Now,
All the sides are equal and all the angles are equal.
all the sides are equal. And what about the parallel sides?
Parallel. All opposite sides are parallel.
Then angles?
All the angles are right angles.
Okay. So somebody say, when do we call a quadrilateral square?
All sides are equal and parallel and angles.
What is that? All sides are equal and parallel. Huh?
Yeah.
Is that so?
All the sides are equal and opposite sides are parallel.
And
all the sides are right angles.
All the sides are.
All the angles are right
All the
angles.
angles are right angles.
Yes, exactly. All the angles. So for a square, all the sides are equal and opposite sides are parallel and all the angles are right angles. Right angle. Okay. Then place the name slip as square. Got it? So here we have to follow the same order, whatever. So we started with the
Common quadrilateral.
common quadrilateral and then we went to
Trapezium.
trapezium, then
Parallelogram.
parallelogram,
Right
then
angle.
rectangle,
Rhombus.
rhombus,
Rhombus.
height,
And square.
square. Okay. Yeah. So you have to follow the same order. Okay. I'll tell you why. Okay. And now you know. Now just go back and read the prerequisite. One of you.
Polygons, parallel lines, and angles.
Yeah. So now you know why do we need all these before going to this presentation, because we are discussing about all these with each shape, right? So that we needed that. Okay. And one more thing. Why do we need to follow the same order? Anybody?
From irregular polygon to regular polygon.
From the
We started from irregular polygon.
most
The
irregular.
most irregular.
Because none of the sides are equal, none of the angles are equal there, and we didn't have any parallel lines also there. Do we have any parallel lines in the common quadrilateral? We didn't have, right? All the angles also not equal, so none of them. We don't have any thing there. So we started. That is the most irregular quadrilateral we have. So we started with the common quadrilateral, and we end up with the square, which is most regular.
Regular polygon.
Which is the most regular polygon. So a most regular quadrilateral, right? So, and in between also the order has to be same. Just observe the order. And when we are coming to the next class, just tell me, why do we need to follow the order? So we started with the common quadrilateral, but why are we going to the next shape? What was it? The trapezium.
Trapezium.
Yeah. So just go through with the order and tell me in the next class. Okay. Yeah. So any doubts still here we have? So when you are looking into the presentation, so here we are taking any one quadrilateral and we are discussing about the, we want the children to observe the sides, whether they are equal or not, and how many equal sides we have, right? And also we are discussing about the parallel lines and then the angles, right? So what is the purpose of the presentation? Not only simply learning the names. What did you observe in the presentation? When we are discussing about each shape, what did you observe?
We learned about the sides and the angles and the comparing those with the other shapes.
Comparing those with the other shape. Okay.
Sides, angle.
To identify the lines and angles.
Parallel define a particular shape.
Yes, exactly. So here you can observe, right? After discussing about each shape, we were telling like, so for a quadrilateral to be square, what is the criteria? Right? What has to be satisfied for it to be a square? For it to be a trapezium? That is what we discussed, right? Here, not only just learning the names and properties. Okay, what is the criteria for a shape to be called a particular name? That is what we discussed, right? Got it? Okay, what could be the follow-up activities after this? What happened? Suddenly you're all
Student can make shapes using
And they can write the definitions for each shape, ma'am.
Yes, yes, exactly. They can make their own definitions, write it. Okay, and then what else?
Booklet, ma'am. Booklet.
Booklet of shapes. Okay, then
By using all the shapes, they can draw.
They
can draw some figures.
Okay, yeah. Using all the shapes, all the quadrilaterals you are saying.
Yes.
You're talking about making the designs, right?
Yes, ma'am.
Okay, if I'm not wrong. Okay, then what else can be done?
The children can make the paper cutouts of the shape.
Paper cutout of the shape. Yes. Okay. Yes, they can actually. Yeah, as you said, they can make the paper cutout and they can paste it. They can do it very well. Then what else can you think of? Can we make the same quadrilaterals? Can you think of any other things other than the geometry cabinet and the stick box?
We can use ice cream sticks for making those shapes.
Okay. Yeah, toothpicks, everything you can do. And then yeah.
Study about the correlation between two shapes.
Correlation
Square
between
and rhombus are interrelated, and parallelogram and rectangle are interrelated. One is the other, actually.
Yes, actually, you are leading to the next presentation. That is what you are going to be. That is what going to be your next presentation. Okay, the relationship between the shapes. Okay, yeah. Now, also the children, they can make a comparison table also, right? Between all these shapes, they can make a comparison also, right? Okay, yeah. So all these are the things. Okay. So any other doubts till now we have in geometry?
Ma'am, we have seen on school children were making shapes with like sticks outside the coconut sticks, no ma'am. They made some shapes and named it, ma'am.
Okay. How did they join the coconut stick? They fixed it on the
just leaving down on the floor and making the shapes out of it and naming the shapes with the name slips.
Okay. Yeah, yeah. Good. Yes. Yeah. So, yeah, coming back to the first question that we started with the session. Okay. So, the material that we can compare with the stick box, which material it is?
Small movable alphabet.
So, what are the similarities you see? Go one by one. Charlene, you want to say? What happened? Huh? You were sleeping? No. No. Okay. Unmute yourself. So what are the similarities between those two materials?
Shall I?
Yes. Yes.
Stick box constructing helps to constructing shapes and move constructing words with them.
And constructing words. Okay. Yeah.
Both have compartments.
Okay.
Next,
okay.
with that, make triangle, quadrilateral, polygon shapes. And with that, we can make prefix, suffix words.
Not only that, okay, yeah. So we can analyze the words, right? There.
Analyze the words by symbols, ma'am.
We can do infinitive words
doing different shapes using lines.
Like we studied about the nomenclature, right? Nomenclature of each shape. Just now we discussed, right? How a rhombus is made, how a square is made. So like that, you can discuss more, right? What it is made up of, the word, what it is made up of, right?
Sounds.
Yeah.
Ma'am, and the units are many in number in both the things.
Okay.
Okay, Sangeeta.
Yes, ma'am. Yeah.
Thank you.
Yeah, thank you, ma'am. Thank you. Yes. Anything else? Sorry, I missed out. What did you say?
Ma'am, units are many in numbers, I said. Like
units are many numbers.
Yeah, if we take A, it is 5. Here also it is small one, it is 5 to 7 numbers like that. So we can engage many children with that material.
Okay, not only many children, actually for a shape itself, when you think of a word, you cannot make a word only with those 26 letters. So many times you need to repeat the many alphabets within a word itself, right? So like that, as we made the shapes, within the shape itself, you need many different sticks also you need, right? Okay, so yeah.
And we, in both the cases,
nice observation. Yes. Yes,
moved,
Suchi?
in both the cases, we move from something simple, and then the children build on it to, work independently to make more complex words, more complex shapes. But they start with something simple, and once they've understood how to use the material and the concept, they just keep building on it and moving from simplicity to complex.
Yes. Yeah. Anything else?
You can go from complex to simple.
They go from complex to simple. How?
From compound words you come down to simple words.
Yes. Yeah. So the same thing happens here also. How? With the stick box.
Most irregular to the most regular shape.
No. Actually, she is talking about the single word. The compound word is a single word. Post box. When you take post box, it is a compound word, right? When I split those two words, the single word into two parts, I get post and box. They give different meaning, right? Okay, the same scenario, think about with the stick box. I made a...
From lines to line segment to me. I can divide a square with a diagonal and divide it as two triangles.
Yes, exactly. And even to the line segment, you can decompose. Right?
Dismantle the whole figure.
So deconstruction, like as you construct from the line segment to a shape, so the same shape can be reconstructed towards the line segment. So even a line segment, as you said, in between we have many steps, like any shape can be divided into a triangle, right? That and all you can make, but at the end, actually, you can decompose or deconstruct towards the line segment, right? So just think about it. When you get any different idea or thought about this comparison, please bring it out, right? Okay, so are you all clear with the assignment? The blue scalene triangle, right?
No.
Okay, and yeah, that's all. Yeah, any other doubts? Let's close the session. 6 only used to close, right? Okay. Any doubts or anything we need to discuss?
Ma'am, tomorrow we have presentations. So, ma'am, first session, is it?
First session only, I think. Okay.
How much time does each?
1 minute. Message from ma'am. I just read out. We'll meet tomorrow at the center for sessions and practice. Okay. Their presentation on the second plane child could happen next Thursday. Next Thursday only you have the presentation on second plane child. Okay. But tomorrow you have practice sessions and sessions also.
So morning classes and then afternoon?
Yeah. The usual thing we do, right? Morning sessions and afternoon we'll have.
Ma'am, will you be available tomorrow, ma'am?
Ma'am, sorry, in the first session we have the practice session and the next session we have the lectures.
That is what I'm not clear. We'll just check with ma'am. She has gone to yoga class actually.
Because you know, ma'am, tomorrow we have an event in school, so we will, me and Tanvi ma'am, we both won't be attending the classes. Maybe it is going to go till 3 o'clock. So maybe in
morning,
the second half.
You have it in the morning, Neha?
Yes, ma'am. It starts from like 10 o'clock around, and it will go up to 2 or 3 o'clock. So we probably
Ma'am, I think
I think we have already mailed Kavita ma'am for the same.
Yes, ma'am. We have got the approval of tomorrow's leave actually. We are on leave.
Okay, I think morning only we have sessions and afternoon we have practice as usual.
Okay.
Okay, yeah, that will confirm with ma'am when she is back.
So ma'am, whatever we are missing out on tomorrow, so how do we get that, ma'am?
We'll figure it out, right?
Yes, ma'am.
Ma'am, so 9:30 tomorrow? Is it 9:30?
9 o'clock.
9 o'clock as usual.
Ma'am, actually, we all have doubt and constructions, ma'am. We wanted to clear it with you.
Oh, construction. So you're bringing it tomorrow?
I'll get it, ma'am. We have just a single doubt. If one is cleared, we will do all the others.
Okay, yeah, bring it tomorrow. We'll just discuss at the center.
Okay.
Right? Okay, we'll meet there. Okay, yeah. Shall we close?
Yeah.
Yeah. Okay.
Thank
yeah.
Thank you, ma'am.
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 Bye, ma'am. Thank you,
Bye,
ma'am.
ma'am. Thank you, ma'am.